Greetings, pre-calculus students, to another lesson in our unit on trig, and more specifically radians. In today's lesson, we are going to continue discussing what we started in yesterday's lesson, which is this idea of really connecting this idea of a radian to an arc length around a circle. So we'll start off with a just quick recap of, what happened there? We'll start off with a quick recap of the formula that was discovered in class yesterday, which is the following: that the arc length is equal to the radius times the central angle. And don't forget, though, the one minor detail that is important when using this formula is that if you want to use this formula, you have to make sure that your central angle is measured in radians. If your central angle is not measured in radians, then you have to make sure you convert that angle from degrees to radians, which is actually one thing we will be discussing today. All right, so let's get to our problems here. So the first problem that we're going to do, is going to be, for some of you, might be a little bit of review from yesterday. For others, it might be completely new. So we have an arc length of 2.5 feet. We don't know what the radius of the circle is, but we do know that the central angle is pi over 5 radians. So we're just going to use that formula and set up our equation. So just remember, the formula was arc length is equal to the radius times the central angle in radians, which in this case we have that, so we don't have to worry about converting or anything like that. So in this case we have 2.5 because that is our arc length. We don't know what the radius is, and then we do know that the central angle is pi over 5 radians. So now we just have to solve for r. We have to get r by itself. So at this point it just becomes an algebra problem of trying to solve for a variable. Well, since we have r times pi over 5, right, r times pi over 5, in order to cancel out that pi over 5, we can divide by pi over 5. Okay, so in order to cancel out multiplication by pi over 5, we can divide by pi over 5. So that cancels that out, and on the right side we are left with 2.5 divided by pi over 5. And then we just plug that into a calculator, we get our answer. Now, that's one way you can do it. The other way you can do it, and this basically applies to any time where you have a fraction that you want to get rid of. Another way we can do it is, so we had 2.5 is equal to r times pi over 5. Another way we can do it is, since we have a fraction of pi divided by 5, we can get rid of the 5 first. So we can get rid of the division by 5 by multiplying both sides by 5. Okay, so we get rid of the division by 5 by multiplying both sides by 5. And by doing so, the right side, those cancel out. And on the left side, we are left with 5 times 2.5, which if we calculate that, we get 12.5. So we end up with 12.5 is equal to r times pi. And now at this point, we just have to get rid of the pi by dividing both sides by pi. So that cancels out. And we are left with 12.5 divided by pi is equal to r. Okay, and then the same thing happened on this side as well. So these are both the same answer. Just arrived at 2 different ways. And at this point, if we were to plug our answer into a calculator and round to 3 decimal places, we would get 12.5 divided by pi. We would get around 3.979. Once again, if we rounded to 3 decimal places, 3.979. And in this case, it would be feet, because that is the unit that we started off with. Okay, so once again, whether you do it this way or whether you do it this way, you get the same answer. Okay, so once again, that might have been a review for some of you. For others, that might have been the first time you did a problem which we were not solving for the arc length. Okay, now let's look at B. Now B is going to be just like A. Okay, B is going to be just like A. So for B, I want you to do on your own. Okay, I want you to do B on your own. And I do want you to submit it with your notes. So I do want you to do B on your own and submit it with your notes So once again, B is just like A. So let's look at C. So C as well, though it is not exactly like A and B, in this case, you would still be solving it basically the same way because your setup would be, this time around, 17 is equal to 2 times your central angle. So this time you're just getting C by itself. So that one you can do on your own as well. And once again, you will be submitting this with your notes as well. Okay, solve that on your own. Now let's look at D, because D, this is where we start getting into something a little bit different. So D is similar to C, where you're given the arc length and you're given the radius, but this time you are asked to find the central angle in degrees, not in radians, but in degrees. Well, let's set it up just like we normally would. Okay, let's set it up like we normally would. So we have 9 is equal to 12 times the central angle, which we'll just call C. Well, okay. Well, I hope this seems pretty straightforward, right? We have 12 times C, so if we want to get rid of it, we got to divide both sides by 12. Cancels out. And you're left with 9 divided by 12, which I'm going to write it as a fraction. You can write it as a decimal, so I'm going to write it as 3/4 equals C. Okay? Now, once again, don't forget the formula says that the central angle is in radians. So our answer, at least for the moment, is in radians. Okay, so our answer for the moment is in radians. So let me actually specify that. So this is 3/4 radians. Okay. But we got to determine what the angle is in degrees. Okay, we have to determine what the angle is in degrees. So there's basically there's one of two ways I will introduce how to determine what is our angle in degrees given the radians. So the first way is using proportions. All right, so some of you might be very familiar with setting up equivalent proportions so that you can solve for the variable. Okay. So if you recall from the circle, we know that from the circle, okay, we know that half a circle corresponds to a radian measure of pi. Pi radians is half a circle. And we also know that that is also going to correspond to a central angle of 180 degrees. Actually, a more appropriate way would be. Okay, so pi radians, or 180 degrees. Okay? So half a circle. Well, why is that important? Well, that's the proportion that we're going to use to help us solve this. So we're going to set it up as, let's see, 4 degrees. Okay. We're going to set this up as 180 degrees over pi radians. Okay, because they're equivalent to each other. An angle measure of 180 degrees is the same thing as an angle measure of pi radians. Okay, so if you recall, the way proportions are set up is we have to make sure our units correspond to each other. So since I put 180 degrees on top of this fraction, I have to put the angle that we're solving for, that's also going to be in degrees. So the x, the variable that we're trying to solve for, is going to be the angle that we're trying to determine in degrees. And at the bottom we have 3/4, right? Because we had 3/4 radians. So now we just solve this. We have to get x by itself. Okay, we have to get x by itself. So some students at this point just like to cross multiply, which you can, but this shouldn't be that tricky because we could just multiply both sides by 3/4. But for the sake of, I guess, consistency, let's cross multiply. Because in some problems, cross multiplication will actually be easier. Let's cross multiply this with this. Okay. So once again, 180 times 3/4. So 180 times 3/4 is equal to pi times x. So that's what I mean by cross multiply. Okay, so 180 times 3/4, plug that into a calculator, you get 135 degrees. And then on the other side, we end up with pi times x. Well, once again, we have something times x, so in order to get rid of that something, we divide both sides by pi. So we have 135 divided by pi is equal to pi times x divided by pi. Once again, the pi's cancel out. And we're left with 135 degrees divided by pi is equal to x. So let's plug that into our calculators, and you should end up with an angle that is around 42.972 degrees. So 42.972 degrees, that would be our central angle. Okay, so that's one way in which you can convert from radians to degrees. Okay, by setting up a proportion with 180 degrees over pi, and then the other side the appropriate amount, cross multiplying, getting the variable by itself. So that's one way. Another way is a bit more is quicker, but it requires some, what's the word I'm looking for here? It requires remembering a formula, basically. So there is a formula to convert from radians to degrees, and it's the following. You take your angle, so 3/4, so that's method one. You take your angle and you multiply it by 180 degrees over pi. Okay, so you take your angle and you multiply it by 180 degrees over pi. And that gives you the same answer, which is 42.972 degrees. So that's method 2. Okay. That is method 2. Okay, so you can either set up a proportion or just remember that to convert from radians to degrees, you have to multiply by we call this a conversion factor, basically 180 degrees over pi. Okay. Which actually brings me to a formula, formula that I want to, where is it? Okay, here we go. Okay, so back to this idea of important formulas going forward. So we talked about this one already. Okay, we'll talk about that one. So just ignore this one for now. And just ignore this one for now. We'll talk about it in a second. So converting from radians to degrees, multiply your angle by 180 degrees over pi. Okay, so 180 degrees over pi gives you your angle in degrees. Once again, if you already have radians. Okay, let me see if I do this. Discard. Cool. All right. So we just saw our first problem where we had to convert from radians to degrees to get to our final answer. So now let's look at E. Let's look at E because now we have to do the reverse. Now we have to convert from degrees to radians. Okay? So once again, the formula is arc length is equal to radius times the central angle. But be careful this time, people. We can't just put r times 15. Our central angle has to be in radians. So once again, you have two choices. Either you can set up a proportion. Okay, so we can do pi over 180 degrees is equal to x over 15 degrees. Okay, so we got to make sure, once again, that the units line up nicely. If I put degrees in the denominator, then it has to be degrees in the denominator in both. And we can cross multiply. So 15 times pi is equal to 180 times x. And then I can simply divide both sides by 180. Okay, divide both sides by 180. And I am going to actually, you can simplify this fraction. So I'm going to simplify this fraction, 15 over 180. It simplifies to 1 over 12. Okay, so 15 over 180 simplifies to 1 over 12. So that means our answer is 1 pi over 12 is equal to x. Okay, and it simplifies to 1 over 12 because 15 goes into 15 one time and 15 goes into 180 12 times. So that is our angle in radians, pi over 12. So that is what we would be using, pi over 12 in our formula. Or you can do method 2, which is a simple conversion formula just like the previous problem, except this time we're going from degrees to radians. So to go from degrees to radians, you have to do the angle, so in this case 15 degrees, times pi over 180. Okay, so the angle times pi over 180. And you're basically left in the same spot. You have 15 pi over 180. The 15 and the 180 can simplify to 1 pi over 12. Okay, so method 1, method 2. Similar to the previous problem, either you can use a straightforward formula in method 2, or you can set up a proportion in method 1. Whichever you find easier, you go for it. Okay, so now we got to solve for r. So at this point, it's similar to those first two problems that we tried out. Excuse me. So the way I'm going to do it is I'm going to multiply both sides by 12. So 12 times 35, let's see, can I do that off the top of my head? I think it's 420. Yeah, 420. So 420 is equal to r times pi, and then we divide both sides by pi. So that means r is equal to, let me put a separating line here. R is equal to 420 divided by pi, which is approximately, if we rounded it, if we wanted to round it, we would plug it into a calculator. Otherwise, we would just leave it. That means the radius of this circle is 133.690 centimeters. Okay. So that brings us to our third and last important formula. If I go back here, it's the one that I initially crossed off, which is, to convert from degrees to radians, you multiply the angle by pi over 180, pi over 180. And then from radians to degrees, it's 180 over pi. An easy way to remember which one, because they're basically just the same, just upside down. The easiest way to remember which one is if you start off with degrees, that means your denominator will also be degrees. So 180 degrees in the denominator. If you start off with radians, your denominator will be pi radians as well. So those always match up. What you start with is going to be the number that matches in the bottom, if that makes sense. So if you start with degrees, that means you have to have 180 degrees on the bottom. If you start with radians, you have to have pi radians on the bottom. And then the top, obviously, is just the other number. All right. Okay. So now let's go over one more example. So we were here. So this is E. So now for F, F is basically the same thing. It's a little bit different. The setup is a little bit different because this time we don't know what the arc length is. We know what the radius is, but we can't plug in 24 degrees yet. You have to convert 24 degrees into radians, and that you will do on your own. And you will be submitting that with your notes as well. Okay? So another problem I want you to try out on your own. All right. Example 2. To the nearest inch, so now let's look at a circle. That's not just a circle, but it's actually a pizza. So to the nearest inch, find the arc length of a pizza slice that has a central angle of 6 degrees. The radius of the pizza is 12 inches. Okay? So we're trying to find arc length. We know the radius is 12, but we have 6 degrees. And in order for us to plug in the angle into the formula, it has to be in terms of radians. It has to be in terms of radians. So for the purposes of this example, I'm just going to use the formula. So I'm going to do 6 degrees times pi over 180 degrees. So that gives me 6 pi over 180. 6 goes into 6 once, and 6 goes into 180 30 times. So that means I have 1 pi over 30 radians. So 1 pi over 30 radians. So that's my central angle measure. That's my central angle measure. So 1 pi over 30, and you can write radians. You don't have to write radians at this point. Okay? So now we just multiply. Well, let's see. So this is 12 pi over 30. I can simplify that fraction a little bit. 6 goes into 12 twice. 6 goes into 12 twice. And 6 goes into 30 5 times. So the simplified fraction would be 2 pi over 5. But, now let's plug it into a calculator and get an answer. To the nearest inch. Okay, so to the nearest whole number. So to the nearest whole number, it's 1. It's 1 inch. Okay, so the radius of this pizza... I'm sorry, well, not the radius. I apologize. For a second there, I was about to say that's a pretty small pizza if the radius is only 1 inch. No, the arc length of this slice is 1 inch, which is actually pretty small too. That's pretty thin if you think about it. So think about the crust. The crust of this pizza is only going to be 1 inch long. So that's not a very big slice of the pizza. So there you go. And then, of course, in example 3, it's going to be a problem once again that you will be trying out on your own. Okay. So that was it for today's lesson. As usual, if anybody has any questions, just please leave them in the classroom. Remember those 3 formulas that we talked about in this lesson. Arc length is equal to radius times central angle. To convert from degrees to radians, you multiply the angle by pi over 180. And then finally, to convert from radians to degrees, you multiply the angle by 180 over pi. All right. Otherwise, I hope you guys stay safe. And I will see you in our next lesson.